Hey everybody, it's Tony from Adafruit, and if you've tuned in a little earlier, you probably saw me do this stream, and it crashed kind of midstream, so I'm starting it over, so we'll just start fresh. So this is part 4 of the Raspberry Pi Internet Thing video series, and this will be the conclusion, the exciting conclusion, where I'm going to add real-time capabilities to the web page so that it's instantly updating as soon as there's a new sensor reading, like the temperature or the humidity changes, it'll push it out to the web page, or as soon as the switch changes state, it'll immediately update on the web page. And it's using some really interesting technology that we'll kind of dive into and talk a little bit about for it. So, I figured this is probably a good part to wrap up this little series on. So it's, just to summarize the series, we've created a thing with Python that has a switch, like a digital I/O line that you can read. It has an LED that you can turn on and off, and it has a temperature humidity sensor, an AM2302 sensor connected to it. And so it's sending that sensor data to the web page, and it's building a chart that updates in real time. So real kind of interesting proof of concept in some ways of like, you want to build some device using a Raspberry Pi that is controlled through a web page. So it shows, sensor data and stuff like that. And hopefully with this series, you've learned a little bit that you can do that now and picked up some good tips. So let's just dive in, and I'll show you what I've got right now for this project. So I'll start with just what we'll end up building at the end of this. And looking at it, if you saw the previous videos, it looks pretty much exactly the same as what we had before. So this is using the Bootstrap UI framework to render nice little web page here. It's got the switch state here, and you might notice it looks a little bit different. So previously the switch state would update every second, so we'd push using server sent events. But now underneath the covers or behind the scenes, I'm using a technology called Socket IO, which sometimes uses WebSockets to do two-way real-time communication. So watch as I pull the wire out connected to this digital input for the switch. It's going to float, and so that means the value is going to toggle between high and low kind of randomly. And you might notice the switch actually shows that state. So see, I pulled it off and it's kind of toggling, and now I'm going to move it over to the high voltage, the 3.3 volt line. And oops, it looks like I kind of missed, got the wrong one. There we go. So now see it's in the on position there. And if I move it back, it's going to toggle a little bit, and then put it back on ground. And oops, kind of missed it there. There we go. So now it's off. So real kind of interesting how, before you could only see every second the new switch state, but now as soon as the switch changes, it's updating on the web page in real time. Now the LED, it's also using this Socket IO technology, so you won't notice much of a change. So like I click on, and you see the LED right here kind of turns on, and then I click off, and it turns off. So just like it was acting or working before, but it's using a different kind of transport underneath the scene or underneath the covers there. And the DHT sensor graph that we had before, so it looks the same. It's updating every 2 seconds, and so now when there's a new sensor reading, it's getting pushed to the web page here. And so if I blow on the sensor, we should see that it changes. So let's see what happens now. So that's going to increase the humidity. And this graph, it's showing 2 different values. So it's showing this kind of blue one on top is the percent of humidity. And so, I blow on it, it sees the humidity from my breath, and so it goes up to like, 90% or so. And then way down here, there's another series on this graph that's the temperature in Celsius. So it's, in like mid-20s or so. So around like 60, 70 degrees Fahrenheit. So that's kind of cool. It's all updating in real time. And so we'll kind of dive in here and talk a little bit about what's powering this and how to do this code in Python. So I first just want to mention the transport protocol that I'm using. So it's called WebSockets, and that's kind of what allows you to do this real-time two-way communication on a web page. And it's a really interesting technology. So it's very similar to sockets in network programming. So things like the web itself, Hypertext Transport Protocol, HTTP, that's built on top of a socket connection, which is just a pipe that you can send and receive bytes through. And so you can add abstractions on top of that, like protocol for serving web pages. And WebSockets came about because people started to do more dynamic things with web pages. So, you wanted to get like instant updates. For example, if you wanted to build like a chat application like Slack or HipChat in a web page, you need some way to know, okay, someone sent a new message, let's print it out, and then I type a message and let's send that to the server instantly. And HTTP as is wasn't really built for that kind of real-time stuff. And people found ways around that. So like in the previous videos, I've been using a technology called server-sent events, which is kind of an evolution of something called long polling, where you keep a web connection open and the server could just periodically send data down to the clients. And so, people were starting to do this, and then they realized, okay, this is important and interesting enough that we should make this a standard itself. So they created WebSockets. And WebSockets are really just a way to do a socket level, a pipe for reading and writing bytes over the web protocol HTTP. So it's using the same port, same kind of connections. There's like a little kind of protocol kind of handshake where you make a web connection, and then there's a socket kind of handshake that says, okay, let's create a WebSocket connection. And once it's created, then from your server side and from your JavaScript web page side, you've basically just got a connection that you can read and write bytes across. And as soon as you write bytes from the server, the client web page can read those bytes and vice versa. So that's the technology that we'll use here to kind of get these real-time updates. And as soon as some state changes, the server can push it down to the web page. And when the web page wants to change something, it can push it back from the server up here. And then the thing that I'm actually using in my code is something called socket.io or socket.io. And it's a really nice library that's kind of an abstraction on top of WebSockets. So like I said before, WebSockets are very low level. It's just a stream of bytes that you can read and write. Whereas socket.io kind of adds a concept of publishing events and receiving events on top of that. And so it does things like it can serialize data into JSON format object so that you can just send an object from your JavaScript web page, and then your Python code can receive that object and decode it as JSON and look at the data. You can publish, you can create different event types. So like I could have an event that says turn on the LED or turn off the LED, or have an event that's like, here's a new temperature and humidity sensor packet that you should use to update the web page. So it's nice to have that abstraction because it simplifies a lot of the code. So you don't have to look at, okay, just reading raw bytes and then deserializing them and then writing raw bytes. You just add the socket.io library and add a few lines of code to send and receive objects. And we'll see that I think that this makes a lot of sense to use a library like this. The other big thing about socket.io that I didn't mention is that it actually has support for both WebSockets, and it can fall back to long polling, which is kind of the older technology. So that, if you're using an older browser that might not support it as well, it can fall back and at least try and find a way that might work for you if you don't have like the latest stuff that uses WebSockets. Now I think most browsers today should support WebSockets. As far as I know, they've been a part of like the HTML5 standard that, if you're using Chrome, Safari, a modern version of IE, like I'm sure like IE 8 Plus or whatever probably supports it. So it's out there and it's a good option, but it's cool to have that in socket.io that it'll do that fallback. You don't have to know or care about that in your code. It just works basically. And then the technology that we're going to use also, because I'm writing this server in Flask, the Python web framework, I'm going to use an extension called Flask socket.io, and it's a really nice extension. Just everything in Flask always impresses me. A lot of the extensions are nice and high quality, so this one's documented really well. It looks like it's a great library. And so it just gives you the capability from a Flask web server to talk over WebSockets and socket.io to a socket.io client on a web page, so you can send and receive different events and things. So we'll look a little bit at this. Before I get too far into this, because I had to restart the stream, let me go to our Twitch dashboard because I realized I don't have the Twitch chat open. So hey, you'll see a little bit of how Twitch works here. So they've got this fun little dashboard page. And then the one big thing when you're broadcasting, click this hide video preview because it's going to waste your bandwidth and things will hurt when you have limited bandwidth. So okay, let me pop out the chat and then I can look at this. Okay, cool. And if you have questions, throw them in the chat. And also I should say, all the things I just mentioned on these websites, when this video is on YouTube, look down in the description and I'll have links to all these there too. And also links to the previous 3 videos in this series. So the first one starts from kind of ground zero of like, let's just make a web page, and we've worked our way up now to making a fancy real-time web page for this. So okay, so let's dive in. You saw the example here. You know, everything looks pretty cool. Everything works well. It's all real time. And let's just start hacking on the code here and show you how to do this with the code that we have. So let's see. Let me get started here. So I'm connected to my Pi right now. This is actually the server running right now. Now I'm going to close the web page and then kill the server just to stop everything. And I just want to check. I'm going to run the ps command and just see all the running processes. And I just want to make sure Python stopped because, okay, yeah, so it did stop. I did notice, so I'm using Flask's built-in development web server, which every time you read about it, it says it's not a production server, so it sometimes has bugs. I've noticed that sometimes it'll stay running after you quit it. I think maybe sometimes if the web page still has a connection open, that might keep it running. So it's just something to be aware of, and maybe a future series of videos, you know, I might maybe look at, okay, how do you go from using this development server to, you know, using a real Python server, so something that's production ready, where, you know, it's built to be a little more reliable, a little more stable. But the Flask server, I think it's good enough for just, you know, me personally building a device that only I'm going to use. I'm going to use the Flask server because it's easy and it works. You know, I don't need to support like thousands of connections and, you know, hundreds of requests per second. Keep it simple, basically. So, okay, so we've got our code. And I'm going to start in this part 4 directory, and this is just the Atom text editor. I have it connected to my Raspberry Pi. I use this little app called Mac Fusion. It's a really nice little app. It lets you mount your Raspberry Pi as a file system on a Macintosh computer, and then so it's just, you know, it's using SSH internally to copy files over. And I created a folder called part 4, and it's just the exact same code as we had in part 3 inside of here. So we'll start here to start modifying the code. Now the first thing I wanted to do, to use Socket.io, we need to add the client library that it has. So your JavaScript web page needs to load a Socket.io client, and then our server needs to use that Flask Socket.io extension to add Socket.io. So first let's start with the JavaScript side. And to download Socket.io, it looks like they've got a little download here. And Socket.io itself has two parts. There's a Node.js server that you can use to write like server-side code in, but you don't have to use that. You can use, like, you know, Python and Flask Socket.io, or I'm sure they have all kinds of other servers and things. But then there's also the Socket.io client, which is just a JavaScript file that your web page should load, and that's what we want to do. Now they mentioned they actually have a CDN you can use, which that's probably the right way to do it. But because I want this to be a standalone device, I want to actually include this file on my Pi so that, you know, if I don't have an internet connection, I can still get the data and view the web page. So to get it, it says you go to the repository and you just pull down the latest version of the socket.io.js. So I will grab a link to this, and then we will put it on the Pi. So I'm just going to go to the raw link, I'll copy it, and then I need to go into the static folder, because remember, that's where Flask puts all the static assets, and I have a JS folder for my JavaScript files. So this has, you know, things like Bootstrap, the chart.js library. So let's just add that socket.io.js. I'm just going to wget the file into here, and so we should see the file now. Oh, and oh, interesting, it's already in here. Let me just make sure that I'm not using. Okay, yeah, this is the old code. Okay, so I must have copied it in here before, or actually, oh no, sorry, I'm in the wrong directory here. Let's jump back up to the actual part 4. I was actually in the code on GitHub. I've already uploaded it, and so I've also got a copy here. Okay, so let's go into the web app, static, JS. Now let's wget this file, and now we'll have it, and we can see, okay, so there it is. And if you just want to look at it, it's just JavaScript, so, you know, it's all kinds of code here for it. So okay, so now we've got that. Now I need to actually include it into my web page. So I'm going to go to the templates and the index.js. That's like our main web page template. And I've already got a spot where I'm loading all my JavaScript, and so I'm just going to copy this line, and we'll just tweak it a little bit. And, you know, remember, we're using that URL4 to get a URL to the static location. And here we need to change this to socket.io.js. Okay, so that's pretty easy. You know, it just loads the JavaScript file. So now to start using Socket.io, what I was going to do was look at Flask Socket.io. So they've got some nice little examples here. So they kind of show basically here's from the Flask side how to use the library, and we'll get to that in a little bit. But first, from the web page side, they show, okay, here's how to use the Socket.io library. And Socket.io's website also shows a lot of documentation for this too. So they've got, like, here's how to get started with it. So that's also good to check out. But yeah, I think Flask, this was a little bit simpler. So it's pretty easy though. Like, you just create an object and you call this io.connect function, and you point it at the domain that you want to connect to. And I should also preface this and say I'm pretty new to Socket.io. I've just started using it in the last week or so. So I'm sure if I say something wrong, I'm sorry about that. But from what I understand, I think that Socket.io, I don't think it has a concept of like a path. Like, you can't do your web page / socket. Like, right now in my Flask app, I have different routes, like, the /LED route. I don't think Socket.io has that concept of, like, high-level URLs. It does have an internal concept of like a namespace where you can create different paths that are distinct from each other and have distinct events. But I don't think that you can actually say, like, have two different Socket.io instances on different paths. I think you've just got one instance for the whole server. But you can have all kinds of different event types inside of there, so it doesn't really limit you. But basically, so you'd call this IO connect, you get back a socket object, and then you can just attach event handlers to this. And there are different events that Socket.io has. So there's one for, like, when it connects to the server, it can fire an event. When it disconnects, it can fire an event that you add code to. When it receives a special event, it can fire an event that you can run some code off of. So let's just take their code and let's see how this works. So it looks like they're basically just printing a message when you connect to the server. So let's go into our JavaScript code. So this is the code that runs once jQuery is loaded and it sees that all of the JavaScript has finished loading. So let's just put at the bottom here their code. So we'll create this socket object and it's going to connect. Now I'm going to change, this is something I kind of noticed from just playing around. If I don't put any parameters to the IO connect, it looks like it just connects to the web page itself, which is fine. So, I could build a URL to my Raspberry Pi localhost, and I'd probably want to use this URL for function. But it looks like if you don't specify any URL, it does the right thing, and it just assumes, okay, you must want to connect to the server that serves this web page. So it does that. Let's keep this, we'll register this connect event, and instead of emitting something, so this is how the client web page can push data down to the server, but I'm not ready for that yet. Let's just put a console.log and say, connected. So just tell us that everything's working and we've got a Socket.io connection. Now this won't work yet because I don't have Socket.io on my server yet. So let's do that next. So to use Socket.io on my Flask server, we're going to use the Flask Socket.io extension. Very easy to install it. So you just do pip install Flask Socket.io. So I'll do that. Make sure to do it as sudo on the Pi because it needs to install globally. So sudo pip install flask -socket.io. And this will probably say I already have it installed, but real simple little library to install. Now it talks a little bit about, it has some requirements. So, it needs a special type of server to run. And it has a couple different servers that it supports. So it can use this eventlet model or a G-event model. And these are just two different models for network programming in Python. So, there are lots of ways to do network programming. For the long time, a lot of people would do a threaded model where, you imagine a web server, and every time someone connects to it, your server needs to run some code. And so an easy way to do that would just be, okay, a connection comes in, I'm going to spin up a separate thread. It can run my application code, so when the user requests new data, that thread can process it. And if multiple users want to access my server, it's just going to spin up a thread per user. But over time, people started to see there are a lot of bottlenecks with multi-threading, especially very high levels, like when you want to do thousands, and I think some web servers can even do up to millions of connections per second. To get to that level of performance, you need to really optimize all your resources, and threads are just another type of resource. There's only so many threads you can have before, like, your CPU is just thrashing, trying to give each thread a little bit of slice of time. So something that's been real popular in the last 5-10 years or so has been, using more of kind of a I guess I call it the Node.js model, where you're polling for events. You don't necessarily have threads. You've just got one main loop running, and you have different lightweight processes, not necessarily process, but you've got some code that you can run, and it's not in a thread, it's just in your main loop. So you're just waiting for like some new a new connection to come in or some new data to be received, and when that occurs, you can go and run your code without pushing it off into a thread. And so it has it's a trade-off. It's not necessarily better than using threads, not necessarily worse than using threads. It just means like you don't have the overhead of each connection creating a thread, but there are other performance limits too sometimes with it. And so from what I understand, Eventlet and gEvent use that type of model where they don't necessarily use threads. The name escapes me. There's sometimes a name for this kind of style of programming, but it's a very asynchronous style, where you have this single loop, and it just goes through and looks at, okay, here's all the different things that I want to run, and it gives each one a little bit of time, almost like your code is replacing what the kernel does for giving each thread a slice of time. You're doing that yourself in some ways, but you've got a lot more control over it since you can do it. But so we're not going to use those. Those are nice production ready, quote unquote, web servers, and that they're built to handle thousands and lots and lots of requests per second. But luckily the library also supports the Flask development server, and so that's what I'm using here. Simple little server that Flask has, and luckily you don't really need to worry about this. So it's a nice little library in that it'll look and see what do you have installed. Do you have Eventlet? Do you have gEvent? And if you don't have those, it just uses the Flask server. Now it also talks about it can do really fancy stuff, and we're just going to use the simplest socket.io stuff in this example. I'm just going to publish events and receive events, but you can do all kinds of things. Like you can have multiple worker processes across multiple machines, and they can all push events into a central queue, and then that can get pushed out to all your connected clients. So there's really cool stuff you can do with this, but again, we're just going to keep it simple for here. So now let's see, I've installed Flask. I just did the pip install, the Flask socket.io, and let's start adding in the basic code. So to use socket.io, the extension, I just need to add this to my main. So let's go to our main and jump up to the top here. So after I import Flask, we'll import socket.io, and then let's see, I need to create a socket.io object here, and they show creating the secret key. I think this is used for Flask's kind of state that it connection specific state. Ideally, like, you probably want to set this to some random value. I'm not going to set it, so maybe this isn't the most secure app in the world, but it's just for kind of demonstration purposes. So okay, so now after I load socket.io, I need to create this socket.io object, and you feed it your Flask application, and then it figures out, okay, you're going to use the Flask development web server, and sets itself up for that. Okay, now that I have the socket.io object, there's one other thing. When I run my server, I need to change how I start it. So I need to call this socket.io run and then send it my application. And so this will let socket.io do its thing, and it'll use Flask's web server, development server internally. So I give it my app, and then it can also take the same parameters as the Flask development web server, except for this threaded parameter. I noticed that it actually sets threaded true internally, and if I try to set it also, then it kind of collides and you get an error. So basically host and debug you can set, but threaded, it's setting it for you here. So okay, so let's save this, and now if I run my server, nothing should really change for this example. So let's go back up to the web app directory. Let's do sudo python main.py. You do notice something is a little different though. So it's telling me WebSocket transport not available. Install Eventlet or gEvent for improved performance. So this is kind of cool. This is socket.io. It realized that I don't have these fancier web servers available. It falls back to the Flask web server, but the Flask web server doesn't technically support WebSockets. So, technically I'm not using WebSockets in this example, but the cool thing is my code doesn't know that and doesn't care. So, I could add those servers, upgrade this thing, and then it'll use fancy WebSockets, but it's all transparent to me. So it's falling back, it's using long polling, and that's okay because it's still going to work. So everything's great. So, okay, so let's go to the web page, and if I go to Raspberry Pi 5000, now if I open up the JavaScript console, we should hopefully see there it is. There's our connected event. So this is from the web page in our main file. So way down here at the bottom. So we created our socket.io connection and we registered a connect event and it fired. It just printed out the connected message here. So that's cool. Looks like it's working. Like we've got, you know, at least socket.io on the server and let me connect and it fired this event. So okay, so let's dig in and let's start updating everything. So, you know, ultimately I want you know, all of this things that change on this page to use socket.io. So I was thinking let's start with the LED because right now it's just calling a little REST API that Flask creates. And you can see, you know, I click it, it turns on and off here. Let's change this over to use socket.io. So it's really not too difficult. Let's see, and let me start by, let's close the web page just because I want to stop the development server. So okay, so let's go into our code and let's start from the JavaScript side here. So in JavaScript, way back, actually the very first video I think we did this, we created these little click event handlers and they do a post action against the little endpoint that we created in our Flask app. So there's a route that we have here for the LED state and you can send a 1 or a 0 to turn it on or off. So let's change this over and we're going to, instead of calling a web API, we're going to emit a socket.io event because socket.io basically is built around sending and receiving events, and events can have a payload of data which can be any JavaScript object, or in Python you can basically take a dictionary object and so you can send and receive objects, so you can put whatever data you want inside of there. So let's emit like an LED change event, and then in the payload we can say on or off, like how we want this thing to run or to turn on or off. So let's do that, and I'm actually going to move this code down to the bottom just because that's where I initialize my socket object down here. Technically I don't have to move this because this variable is kind of in the scope, and the code, even if it was above here, could still access this socket variable, but I like to move it down just where, you know, it's being used here. So okay, so instead of calling this web API, we're going to call socket.emit. And so this is going to use a function in socket.io's JavaScript library. And you can actually see in the Flask example here, that's the emit code that they're calling here. Now it takes two parameters. It takes in the event type, and this is just a string you can define. And you don't have to give each event a name. You can actually have unnamed events. But I like to give things names just because it makes it more explicit what I'm doing. And then it just takes a JavaScript object, so, you know, simple, like any kind of dictionary of stuff inside of here, or it could even just take a string. So I'm just going to send a string here. So let's just emit. Let's make a change LED event, and we'll have it emit. So when I click the on button, this is the on button click event handler. Let's just have it send on, and then let's do the same thing but send off for the off button here. So let's grab that, and we'll do off inside of there. So that's pretty easy. I mean, it's one line, same as we had before pretty much. Now in our code to handle this, so this is where our route is in Flask that, you know, receives this data. Now to do the same thing in socket.io, it's very similar. I really like this Flask socket.io library because they don't add a lot of, you know, crazy abstractions here. So basically you just have to register an event handler here, and so the format looks kind of like this. So let's copy this out, and basically you define, you know, you have a little bit of an event description here that says, okay, here's the event I want to listen on, and so in this case I want to use the exact same string as I used in my client, so change LED for example, and then there's just a function we need to define, so let's just call this change LED function, and then it can just take in parameters, and you can have multiple parameters. And if it's a JSON object that it receives, it'll deserialize it as JSON and give it back to you, so you don't have to deserialize it yourself. In this case, I'm just going to say, let's call this state, like this is the new state for the LED. And then the code for this, so it's pretty much almost exactly the same as what we had up here. Let's just grab this if statement and we'll paste it in here. Now my state is a string instead of being a number now, so basically if I want to look if it's on or off, oops, actually this is the off case, and then the on case down here. So yeah, so this is just going to look and see, okay, you know, what's my state that's passed in from socket.io, and if it's on or off, just set the LED accordingly. So let's save this and let's run our server again, and let's see, let me just double check. I'm kind of paranoid that Python is still running sometimes on here, so yeah, I just want to make sure. Okay, good, it's not running. So let's run our main.py. Oops, main.py. And so this will run the server. And now let's see if I connect to it. So if I go to Raspberry Pi. And so it's connected. Okay, now let's see. Let's open up the console just to make sure everything's all good. So, okay, so we're connected. Now here's the big test. Let's click LED on. And look at that. Turned on. Turn it off. On, off. So that's kind of cool. And you can see back here, this is the output of the Flask development web server. And it looks like when Socket.io does a fallback, so it's not really using WebSockets here, it makes like a little REST API, so you can kind of see what's happening when I click that on. But as far as my code is concerned, this could be using WebSockets or it could be using long polling, it doesn't care. So that's cool, that's pretty easy. I mean, you can see we're just creating an event listener, and you know, it's nice in that we don't have to worry about how to serialize and deserialize this data. All of that's taken care of for us. So that's great. So I'm actually going to remove the old route that I had here. You know, I don't need this anymore because I've switched it over to instantly update. Now, it is maybe a good question of like, okay, you know, what's better? Should I use the REST API like I had before, or should I use the Socket.io interface? And I don't think either one, you know, they're both good in different ways. Like the REST API is nice in that anything that can talk HTTP can talk to that REST interface. So like if I had a little ESP8266 board, you know, it could talk to my Python thing and call that API to turn the LED on and off. Versus if I have the Socket.io interface, like sure, it might be a little bit quicker because there's no HTTP overhead. You know, it's already got a socket connection open and it can just quickly send and receive data for it. But anything that wants to control the LED has to talk to Socket.io, which might require using WebSockets, so things get a lot more complex at that point. So it's a trade-off. You know, you need to think about like, are you trying to create something that anything can talk to, or just that a web page can talk to? And in this case, I think we're more focused on the web page. But you know, you could have it as the REST API still, and you could do both. Like you could have, you know, maybe your thing has a REST interface for hardware to talk to, and a fancy WebSocket Socket.io interface for your web page to use. You know, there's nothing wrong with doing it that way too. So okay, so cool. So we've got the LED switched over. Now let's change the switch. So you know, right now the way the switch works, we have this little SSE, server sent event kind of route, and it runs this loop, and it will basically sleep for a second, and then every second, you know, it's going to pull in the new switch state and push it down to the website. And so that's why, like on the web page right now, when I pull this pin off, you don't really see the switch changing. Like, okay, now it changed to on because it's floating, but you know, you didn't see it like toggling really quickly like I did in the final example for this, and that's because it's only sending a new value every second. So let's go in and let's start changing things to make this, you know, as soon as the switch changes, I want to push that state out to the web page. And there's actually a great way we can do this. So using the rpio.gpio library, the Python library, it actually has support for detecting when a digital input changes and firing an event. And there are a lot of ways to do it, but it has this event detection concept. And so you can basically register a callback, so some code here that'll be called when a digital input changes state. And so I'm thinking, let's change our switch logic to be like that, so that my server can register a function that'll be called by our pything code when the switch changes state, and then the server can like publish an event to any connected Socket.io client that says, okay, here's the new switch state for it. So to do this, I'm going to dive in first to our thing.py, and so this is the code that just deals with talking to our hardware. So it's just a simple little Python class. And right now I just have this read switch function. But what I want to do is I want to add a new function that lets you give it a callback function. So this function should take in as a parameter a function, and then it's going to set up the switch digital input so that when it changes, it will call whatever function was registered there. So let's start with just the function that I want to add. Let's say on switch change, let's call it. And this should take one parameter. This will be a callback. And then let's just give it a document string. So register a callback function to be called when the switch changes state. the callback should take one parameter, which is the current switch state, which is a Boolean. So basically, in the callback that this takes in, whenever the switch changes, I'm going to have it send in the current switch state. That just saves having to call my read switch function, because I've already got that knowledge of the new switch state, so I should just pass it down to anyone that calls this. So the way that this works, I'm basically just going to take the callback function that's passed to me and save it as an internal variable. So I'll just say, okay, here's the callback that the user passed in to me, and I'm going to save it in the switch callback. And then in my initialization, I'm going to, let's see, we'll just put it down here, say initialize callbacks. And I'm just going to initialize this to none. So we'll say switch callback equals none. So this basically means when I start out, I'm going to have no callback associated with me. It's only until someone actually calls this on switch change and gives me a callback that I'll save it. And the other kind of limitation here is that you can only have one callback. And I think that's okay. I mean, you could create like a list of callbacks and then have your code go through and iterate and call each of those individually. But I'm not going to do that right now. Okay, so now let's set up rpio.gpio to fire an internal callback when the switch changes. So now let's set up the library rpio.gpio to call a callback. Now I'm not going to call the callback that the user defined, this switch callback, just yet. I'm actually going to make an internal callback that does a little bit of processing, because you'll see why we need to do this, and then that's going to call this switch callback here. So now to do this though, I'm just going to use the code that rpio.gpio library uses, and basically it's this add event detect that I need to use. And I noticed a little bug here. Basically, they say, so there's a concept of switch debouncing built into rpio.gpio, which is really awesome. It's cool that they have that. They say you can use it with this add event callback, but looking at the code, it looks like it actually doesn't have this parameter. So if you want to do debouncing, it looks like you have to use this add event detect function, which isn't bad. It's exactly the same function. So okay, let's copy this in, and this needs to take in the pin. So this is my switch pin. That I've already defined. Now it needs to take in what type of change should fire this event. It can be basically falling, which means it was a high level that went down to a low level, or it can be rising, which means that it went from a low level up to a high level, or you can actually do both, which says if it went high to low or low to high, fire this callback. And that's what I want, because when it changes anyway, when it goes from on to off or off to on, I want this to fire. Now this should be a link to a function to call, like the actual callback, and we'll come back to this in a second. But you can also give a bounce time, and so this is like to debounce the digital input. This is a delay that it will use. So it'll basically, when it sees that the value changes, it's going to wait this bounce time, and then it's going to read the value again. And if it's still changed, then it fires your callback. But if it didn't change, then it won't fire your callback. And that's because, and you can see, like, as I physically move this wire, it floats for a second. So you get random values, and then it settles down once I connect it. Same exact thing can happen in a physical switch, where, as you move that switch, there's a tiny little, sometimes just a few milliseconds of time where it's not connected to anything, and you're getting these weird values for this. So I'm going to use this bounce time. Now this is in milliseconds. They have 200 milliseconds, which is a little long, I think. So I'm going to switch this to 20 milliseconds. But you can tweak this to anything. Now for the callback parameter, I need to give it a function, and I'm actually going to create a new function. So let's do self dot. We'll say not switch callback. Let's say switch changed. So let's make a function then right below this called switch changed. And this actually doesn't take any parameter, or no, sorry, it does take one parameter. It takes in the pin that changed, but unfortunately, it doesn't give you the changed state of the pin. Like, is it high or low? You actually need to call gpio.input and read the current state again. And so that's why, if it gave me back the new state of the pin, then I might actually just have it, use the switch callback that a user registered. But since it's not giving me that back, I'm actually going to read the current state of the pin and then fire whatever user callback exists here. Now this user callback might not be set yet. You know, it might be set to none, and so I want to check that because I can't call the function when it's set to none. You know, that's actually going to crash Python. So I want to look and see if, you know, the user callback is not none. So if my switch callback is not none, then I can call the function. So I can call switch callback. And now here I actually want to do my GPIO.input the switch pin. So I'll read the switch and I'll call the user callback for this inside of here. So okay, not too crazy. I mean, pretty straightforward. Now let's, so this should be all that I need to do in theory. You know, just if I write some code that calls on switch change and I give it a function, that function should be called when the switch changes. So let's try it out. Let's go to our thing test, and here I'm going to, let's create a switch change callback and enable it. So let's make a little function in here. We'll call this switch changed, and this will take in the current switch state. So we'll just put state here, and let's see. Let's just say if it's true, then let's just print out, you know, the switch is on, and otherwise if it's false, we'll just print out the switch is off. Okay, so that should be okay. And then now I need to call my pything dot on switch change, and I need to give it my switch changed function. So now basically I'm going to register it as a callback, and so whenever the switch changes state, we should see this function called, which will print things out. And so the code, it's actually going to go into its main loop where it prints out the humidity and the temperature, and then it toggles the LED. But at the exact same time, because this is going to happen in a background thread that the RPIO GPIO library uses, I should see these switch toggle events as it changes. So, excuse me, let's try it out. Let's see, let me close the web server first and cancel out of this, and just make sure Python stopped. Okay, that's good. Now let's run our thing tests. So thing test.py, and let's see. Oh, I think someone just caught the issue in Twitch chat. So switch change is not defined. Yes, I probably did a little typo here. Let's see. It's in my thing test, line 19. Switch changed. Yep, there we go. So change that. Now let's try it. Okay, so this is cool. So it's printed out, you know, here's the current switch status at the start, and that's using, you know, this code right here. So my read switch function still works. That's all good. Now let's see what happens when I pull this off and move it around. So, well, something failed. So something happened. Let's see, let's put it back. Oh, it looks like another typo here. So I've got a SLF. That should probably be self. So let's go in. Let's see, what function is this in? This is in thing.py line 41. So thing.py line 41. Let's jump up here, and yep, there it is. So one thing, this is what I don't like about dynamic languages like Python, where you don't have a compiler step that can catch errors like this. It's only when you run the code. And so that's why I like to do little test cases like this, where you can run stuff in isolation and see how things are going. So okay, so let's try this again and move this over. So okay, cool. So now it's floating, and now I moved it to on. So, and you can see now it's moved to high level power, and it's the last event that it saw was the switch is on basically here. So that's cool. So that's working. So, you know, basically I've got a callback, and I can move this around, and it's going to fire my code. So let's put that into our server code now. Let's start getting this event sent down to our JavaScript page. So, okay, so our main.py is right here. Now let's see. Let's create a function, a switch changed callback in our code here. So this is just like our test code. We need a function to be called that will register as the callback for switch change. So let's call switch changed, and again it needs to take in the current switch state. So we'll just say state, and here now I want to, you know, instead of printing something out, I'm going to actually emit a socket.io event. And it's kind of interesting. There are a few different ways that you can emit events in socket.io. I think it was the Flask socket.io documentation kind of mentions it here. So like if you have an event receiver, it can emit an event back to whoever called that receiver. Or you can just do a global broadcast where you just say emit an event to everyone connected to the server. And that's what I want to do here, because, you know, if there are multiple people connected to my server, I want to tell them all the switch state changed. And so the way to do that is basically this broadcast concept here, where you want to use this socketio.emit function. And so this is using the high-level socketio object that we created up here. So we're going to call the emit object on this, or function on this, to push out the new state for this. So let's just do that. So let's emit, and let's call this switch changed. Maybe we'll call this event. And then so the data for this, I just need to pass in whatever state I want for the switch. So I'm going to just pass in the state that was passed to me. So this will be like a Boolean. It'll be like a 0 or a 1 value in here. So let's see. Let's save this. And then now in my JavaScript code, I need to receive this event, that switch changed event. And so the way that I do that, I actually just tell socketio that on the switch changed event, call a function, and it's going to pass me the data. I'm just going to call it E, like this is like the event context. Sometimes you see this a lot with like jQuery code. And then inside of here I can do anything with this. So I'm just going to log the data. So let's just do a console.log, and let's just log the E value that we got. So okay, so let's save this, and now let's run our web server. And now let's access the page, and we should hopefully see in the console as I change things. So let's go to the developer console, and okay, so we're connected. Now when I move this pin, we should see, uh-oh, I don't see anything, so there's probably something wrong. Let's see, let's go back to our page here. Okay, so I don't see anything in here, so let's add a little debug statement here in our main.py, and let's just make sure that this, oh, duh, of course I'm not going to get this. I need to register my callback, so I totally forgot to do that. So in my main here, so what I'm going to do before I start the server, so this socketio.run, you know, this is never going to return because now the Flask web server is running and it's doing its own thing. So, you know, I need to make sure to do my setup before that starts. So on my py thing, I need to call onSwitchChange and give it my switch changed function, the one that I just created up above here. So let's do that. So okay, now the Flask server actually just reloaded. So in theory, I can reload my web page. And now let's see when I move this guy around. So okay, well, I still don't see anything changing. So let's see, I must have gotten something wrong in here. Let's see. Oh, it had an error on request. Oh, well, that was actually when I reloaded the page. So okay, so let's go back. Let's start debugging this a little bit. Let's do a print statement in here to say switch changed, and let's print out the value of the switch also. So let's do a format, and here's the current state. Okay, so let's save that, and I'm going to cancel the server, and let's just make sure it's not running. So here, see, notice this Python instance. Oops. Oh, and actually, it looks like it might have just stopped. Let's try this again. So yeah, there you go. So it's a little funky sometimes when you have a web page open and the development server is still running. You sometimes see errors like that. So okay, so let's run my server again. And the reason I do that is because if I tried to run the server and an old instance was running, the new instance wouldn't be able to run, and you'll get an error that it can't bind to port 5000 because something's already open on there. So okay, so now let's go back to our web page and let's see what is wrong with this. So now when I move my switch, I should see, okay, so I am getting a switch change event. Okay, so I know for sure my callback is firing here, but emitting this event for some reason. So it's the switch changed event. Let me make sure that I have the right code in my web page here. And actually, let's just let's cheat a little bit and look at the code that I wrote earlier to see what I did in the JavaScript. Because basically, yeah, okay, no, that's exactly, it's socket on switch change. So interesting why this isn't seeming to work on this the code here. So basically, so I'm registering a switch changed event handler here with socketio, and it should just be receiving my event. I mean, instead of printing it out, let's just print out switch changed so that I can tell for sure if something's happening. And I want to make sure that I have this string exactly the same in both of these places. So, you know, my emit here should be this. And just to double check, let's look at the code that I did earlier too, just to make sure that my main, I'm not doing something different in here. Oh, interesting. So I guess before I was sending a dictionary, a JSON object. So now that I do remember, actually, I believe that this emit only takes JavaScript. Let's go down here. And actually, let's go down to their documentation just to double check this. So I thought I could be fancy. I thought I could do a string, but it looks like you probably can't do that. So this emit object, so this function emits a socket.io event to one or more. A JSON blob can be attached as payloads. Okay, so it looks like you can't just send a string. It looks like you have to put some JSON into it. So like I said, I'm a little bit new to Flask socket.io and socket.io in general, so kind of learning as you go a little bit here. So okay, so let's pull this out and let's just wrap this into a dictionary object. Luckily, it's going to do the JSON serialization internally, so I don't need to worry about that, but I do need to put it into an object that can be JSON serialized. So okay, let's just put in, you know, a dictionary with the switch attribute in it. So now I can do that, and let's save that. Now in my JavaScript code, let's go back and let's just log the object that we're getting back here. So let's delete that, and now let's save that. Okay, and make sure that I save the web server, and let's see, let's delete that old version that I had there. Okay, cool. So let's cancel our web server, and let's see, let me make sure it's not running anymore. So close that, and now let's run the web server. Okay, so now let's access it, and now we should hopefully see, if I open up the console, now let's move the wire, and there we go. So there's all the data streaming in. So okay, so you can see this is just printing out the object that it receives. And it's kind of cool in that it receives exactly the same object I sent in Python. So, you know, I could pass in other attributes here and read them. So, okay, so let's dig in more to the code here, and let's update the logic now so that when it receives this switch change event, let's fire our update switch function. So I've already got a nice little function that just takes in the switch state directly here. So let's call this right now with, let's see, here's the code for it. So let's call update switch, and let's pass in, so this E object is actually this object here, and so it has a switch attribute that I need to read off of it. So let's do the E.switch, and that should be all that I need to do for that. Now, one other thing I'm going to fix, I noticed a bug, and I'm not sure why this works, but this switch value is actually getting returned as a, it's being sent to update switch as a string, whereas update switch is actually checking against integers. It works, but I'm not sure why. It actually should fail. It was failing earlier when I was adding part 4 to this code. So just a little bug fix there. So okay, let's kill the server. Let's kill the process here. And now let's run the server again. Oh, so see here, this is the problem. So Python is still running for some reason. So I'm not sure why the Flask development server sometimes keeps it open, but yeah, I just have to kill 9, the process, so 13799. So now I can run the server. Oops, let's do that. So okay, so now it's running. Now I go to localhost. And now the big test. Let's see if I move the switch. Oh, now you can see it's toggling, and now it's on, and now I toggle it back, and now it's off. So that's cool. So now we're using socket.io basically to receive that switch. So it's as soon as the switch changes, that change is pushed out. And I think that's a pretty big and important change for this app, because previously, you know, I was relying on this kind of 1 second interval to say, okay, every second read the switch. But now, as soon as that switch changes, it's firing out the event and changing the web page. So that's pretty cool, and that's a pretty powerful thing. So let's do some cleanup now. I'm going to pull out the switch from the current update, this like you know, server sent event endpoint. So I'm not going to send that switch state anymore, because now I've got my socket.io stuff to handle that. And then let's see, because I pulled that out, my JavaScript code needs to change a little bit. So this update thing function is called whenever that server sent event channel has some new data. So I'm not going to use that anymore. So let's just pull that out. So now, this really isn't updating the thing state anymore. This is really just updating the temperature and the humidity. So let's kind of change that. And then let's actually change this to be more explicit and take in temperature and humidity as parameters. So I'm basically going to change this code a little bit so that now this only updates the temperature and humidity chart. And now instead of calling update thing right here, I need to call update temp humidity. And I want to actually first parse out the data on this. So we'll say about data equals parse JSON on my e.data. And then I can pass in the temp and the humidity here. So let's do data.temperature and data.humidity. So just a little tweak to the function there. And actually we'll see I'm going to get rid of this because the next thing I wanted to do now is, so I've got the LED, I've got the switch. Let's make this data in the chart get fired off using socket.io. So instead of using that server sent event endpoint. So now to do that, I was thinking, let's take a similar approach as we did for the switch, where you register a callback and then as soon as new data is available, that callback is called. Because what's happening right now is I have a little background thread, and every 2 seconds it reads the new humidity and temperature from the DHT sensor, and right now it just saves it so that you can later call get humidity and get temperature. And so that's good when you're polling for that state. But because I've got a background thread that's updating the data every 2 seconds, I can just have that background thread call a callback that someone registers and says, okay, hey, here's your new temperature, here's your new humidity, do whatever you want, go crazy, emit a socket.io event, print stuff out if you want, anything you want to do in that case. So it makes it a little bit simpler so that, I'm not doing this polling where I'm constantly reading, what's your humidity, what's your humidity, what's your humidity. It's more of a push model where as soon as it changes, because this sensor only has a new reading every 2 seconds. So I could call it every 10 milliseconds, but I'm going to get the same exact reading only until it's been 2 seconds since the last reading. So let's just get rid of all that and just have it fire a callback every 2 seconds that says, here's your new reading, here's your new reading. So let's do the exact same thing as we did for the switch. Let's add a, let's call this on temp humidity change. I could call this on DHT change, but I figured in the public interface for the thing, I didn't want to put DHT into it because, maybe I might change my thing in the future and not use a DHT sensor. Maybe I'll use a higher precision, like an MCP 9808, I think, like a nice little temperature sensor, or maybe a really, like Bosch has some really nice humidity sensors that you could use. So, I didn't want to tie that into my interface for my thing, because that's something to think about, that my thing doesn't really depend on the sensor. It's just a thing that can give temperature and humidity data here. So okay, so I've got my callback function here, and then we'll just say we'll just copy out the text here pretty much and just tweak a little bit of it. Oops, paste that in here. Actually I didn't copy that time. Let's try that. There we go. Okay, it'll be called when the temperature and humidity changes state. Callback should take 2 parameters now, so I'm going to pass in the temperature and the humidity. I'm going to pass in the humidity to the sensor. Okay, so the temperature in degrees Celsius and the humidity in percent. Okay, so just like my switch callback, I'm going to do the exact same kind of thing here. I'm going to have an internal variable that remembers what callback was passed in. So we'll call this temp. Well, now internally I'm going to call this DHT callback just because it's easier to write than temp humidity. Because this is an internal variable that people who use my class shouldn't see. And so, that's where I'm fine using device-specific stuff here. So, okay, save that. Now I need to do the same kind of initialization up here. I want to set it to a default none state, so it's initialized. So we'll say DHT callback. And then now inside of here, I'm not using the RPIO GPIO library. I'm using my Python library, and I've already got all the logic to have this fancy update thread. So I'm just going to put that logic inside the thread. It's going to just call the callback. But again, I want to check that it's not none. Like, make sure that someone has registered a callback before I try to call it. So if self.dht callback is not none, then call the callback. So let's call self.dht callback. And here, I'm actually going to change this class a lot. And I'm going to pull out these humidity and temperature values. And I'm actually just going to completely rip out these functions that get humidity, get temperature, so that you won't be able to call those anymore, because I don't really think they're needed anymore. You know, you've got the callback you can register, and so you can have your code be notified when they change. It doesn't need to remember that anymore. So I'm going to make that change. And so now here, I'm just going to make these local variables instead of changing them on the class. And now I can pass in temperature and humidity to my callback here. So okay, so that's what I need to change in my class. Now let's update our test here to do the same kind of thing. So we'll say create a temp and humidity callback and enable it. So I'll say temp humidity changed, and here it takes the temperature and the humidity. And I can actually just use the exact same print statement that I was using here. So we'll put that in there, and then make sure to register it. So python.on temp humidity change, temp humidity changed function. Okay, so that's cool. And then down here, I don't need to do this logic anymore, where I'm calling to read it. So again, as soon as it changes, it should print it out on here, and it's only going to change every 2 seconds, because that's the rate that my thread in the background, it's going to sleep 2 seconds here. So let's try it. Let's first cancel or stop our web server here. So cancel out of that. And then let's do sudo python main, not main.py, sorry, that's the web server. I want to stop that. Thing test. Okay, so we'll run this. So now it's running, and let's see. So notice every 2 seconds now it's printing out the value. My switch stuff is still working, so I can toggle the switch, and that's fine. But the humidity is also printing out, so every 2 seconds. And this is a little bit of a change, because I was only waiting 1 second in the previous sketch. But like I said, that sensor only updates every 2 seconds, so I was basically getting the same value twice for it. So okay, cool. So let's feed this into our web application. So just like we did the switch state inside of here. So in the main, I'm going to create a new function here. Let's call this temp humidity changed, and this should take in the temperature and the humidity. And then I'm going to do the exact same thing. I'm just going to emit a new event, and let's call this temp humidity changed. And now I know I need to pass in a object here, so let's put temperature, and let's give it the temperature that was passed in, and then we'll just kind of format this a little nicely, and then let's do the humidity. So put that in. Okay, so save that, and now I also know that I need to actually register the callback. So again, we'll do that on temp humidity change. Let's do what was that called? Temp humidity changed function. So okay, so now I'm telling my thing, call this function. When this function gets called, it's going to get passed in the temperature and the humidity, and then it's just going to emit a socket.io event to all the connected clients, and it's going to pass in, here's your current temperature and humidity values for this. Okay, so let's save that. And then the last thing is on the web page. So now I need to add a new little event handler. So let's do socket.on temp humidity changed, and again, this is going to get passed in the thing, or the state that was emitted with this event. And so this has 2 different attributes that I can read, the temperature and the humidity attribute. And so let's call this update temp humidity function that I changed right here. So let's put this in, and it's going to take in the temperature and the humidity. So let's save that. And then the other thing, let's comment out this server sent event stuff so that now the only thing that's going to update the chart is the socket.io temp humidity changed event. And so it's going to call this update temp humidity function, which is just the exact same code as we had before, that adds a new data element to the end of the chart, and then once there's 20 elements, it removes the oldest element from it. So, okay, so let's save this. Now, fingers crossed if I didn't mess anything up, that it should work just like we saw before. So let's run our main.py, and then let's go to our web page. So if I go to Raspberry Pi 5000, and it takes it a second or two, and so it looks like it's working. So now you see, now it's every 2 seconds it's sending a new data value. So before, we were waiting only 1 second, and we were pushing out the temperature and the humidity, but we were pushing out the same value twice effectively there. So this is kind of cool in that as soon as we have a new DHT sensor value, we push it out to our web page, and I'll blow on the sensor so we can see it again. And we should see that it spikes up here in a second. So yeah, there goes the humidity for it, so it's working. So that's pretty cool. So, I think we've pretty much done what I wanted to do, but let's just do a teeny bit of cleanup because, I pulled out this server sent event code, so I don't need this anymore. So let's remove that. And then in my main application here, I don't need this server sent event endpoint code anymore. So let's just delete that whole thing. That's gone. And now let's just kind of look at the code for this. Like, this is pretty cool. It almost fits entirely on one screen here. So, I've got my main route. This is just a standard HTTP route. As soon as this is when the web browser goes to, this Raspberry Pi 5000 address, it grabs the switch state right now because it gives it an initial value to say, here's what the state is, the switch is currently at, and it renders my index template. And then everything else is just, I've got a socket.io event listener so that when I change the LED, so when I click on my web page here and I click LED on, it fires, turns the LED on. So that's just a few lines of code here to receive that event. If your thing had all different kinds of actuators and devices and stuff to change, you could define lots of other event handlers here that have different things that you want to change. And then you saw the code for this is very, very simple as far as to fire that event. So it's just you do the socket.emit, what event you want to emit, and then the data that you want to associate with that. So that's pretty cool. And then the when I want to push data from the server down to the client, you saw I added these callbacks to my thing class. And so whenever the switch changes or the temperature and the humidity changes, it uses the socket.io emit function to push that change out. Now the really cool thing that I wanted to show too, a neat little demo. So let's look at what happens when I have multiple web pages open. So here's one instance of this open, and let's open another. So let's go to Raspberry Pi 5000, and you can see like these are both open. They're both updating at exactly the same time, or at least they should be. So you can see like as a new data point comes in, they both animate here. This one, it can turn the LED on and it turns on. I can click off on this one and it turns off. And then notice this too, as I change the switch, see how it's toggling in both of those? So, that event is actually getting fired off to all the connected clients here in real time. So, they're both getting sent out. And that's all socket.io and Flask socket.io. So, it knows that there are multiple people connected and it's pushing out the state to all of them. But my code doesn't have to know that. It's very simple code as far as it just knows how to receive events and send events. It doesn't know how many people are listening or, all the logistics about how to send that data. So that's a really powerful thing. I think that's a really cool abstraction that socket.io adds to this. So I think that's it. I think that this is, I'll wrap up. I'll consider this the end of the Raspberry Pi Internet Things series. And it's kind of cool to just kind of recap and go through, we started with just taking a switch and an LED and having a web page show the switch state and turn the LED on and off. And if you go back to the first video, I make a very basic web page. I'm not using any fancy Bootstrap or anything like that. And you have to refresh the page itself to see the switch change. But it's simple and it was really easy. I mean, that thing was like 10 lines of code. And then you could see, so in the, in the second video, I added the Bootstrap Framework that gives you a little bit nicer UI. It's a good UI for like programmers like me, that I'm not a front-end developer, but if I use Bootstrap, I make something that looks a little bit nicer than just raw HTML. So that's kind of what we did, in that example. And then in the third video, we added this cool chart down here that updates in real time and kind of shows, here's the current state of our sensor. So we added like that DHT sensor to this, and so it's evolved over time, I think, into an interesting little thing here that's a pretty powerful and interesting kind of application of connecting hardware to a web page. Something that a lot of people are interested in doing. So let's see. So if there are any questions, maybe throw them into the Twitch chat, and I'll take a look at them. Let's see. Let me jump to different view real quick. And like I mentioned before, in the description I have links I'll put into the previous videos and all kinds of details on the links that I mentioned in here too. So let's see. So can you do a part 5 that extends to outside your local network? Oh, good question. So I don't think I'll do a part 5 on this one yet. I don't want to keep going on the same thing, but that's a good one that I'll maybe queue up. If you do want to access things outside of your network, check out something called oh geez, man, I'm blanking on the name. There's a neat thing, shoot, I can't remember the name of it, but it's basically a way, so you want to tunnel across your NAT effectively. So the question is kind of like, how do you extend outside your local network? So like right now I have to access Raspberry Pi 5000, and if I wanted to access this from outside of my network here, I'd have to open up a port on my router and do port forwarding, and then I'd probably need dynamic DNS or like a domain name setup or a static IP address. So you can do that, but there are neat services, and man, I'm totally blanking on the name here. When I remember it though, I'll queue it up. So I do videos also. Every Monday I do a video to look at interesting software and stuff. So I'll see, when I remember that name, I'll queue it up. There's a great service. I'm totally drawing a blank here. I think it starts with an N. It's N something. Oh shoot, no, that's not the name. But anyways though, there's a great little service where you can effectively get like a NAT tunnel that punches through NAT pretty easily without a lot of pain, so that you can basically have a server that runs locally, and then you run this little client, and it connects up to its server, and then you can access its server. So I'm sorry, I'm totally blank, man. I've used it a bunch of times, but anyways, hey, live video sometimes you're on the fly here. So okay, I think that's it. I don't see any other questions. I'll wrap it up. So thanks a lot for watching. Subscribe to youtube.com/Adafruit. You'll see this video, all kinds of other fun projects. Twitch.tv/Adafruit. You can watch this stuff live and see what I'm up to. Every Friday I like to do a Raspberry Pi video like this, something kind of in-depth and fun. I think I'm going to start a new series next week, so we'll kind of see what I'm going to do then. And then Mondays I also like to do live streams and look at interesting Raspberry Pi software. This Monday I was actually thinking I might look at MicroPython, so not Raspberry Pi related, but MicroPython. It runs on the Huzzah ESP8266 board that we have. And there's been an awesome Kickstarter that they just had, really well funded, like way over their goals, so that they're adding a ton of support to the ESP8266. And this is something I did a tutorial on like a year ago, and I want to come back now. I've actually got some of the alpha firmware for all the changes they've added, and so I want to play with it and see what they've added. And you can actually run Python code on a little ESP8266 microcontroller, and very full featured. Like it's got web API or Wi-Fi support, and they're adding stuff like MQTT and web APIs and stuff like that. So tune in maybe this Monday, and I'll see if I can check out what's new in the firmware there. So thanks a lot for watching, and subscribe, like, comment, and I'll see you guys on Monday and Friday next week. Thanks a lot.